For this assignment, you're given a linear equation either in standard form or in slope-intercept form. And you're also given an ordered pair next to your equation, and it's your job to determine whether this ordered pair is a solution or not. So, quick reminder, a linear equation is simply a line. So if I was to graph these equations, they would all look like lines. And what I'm basically asking you to do is figure out whether this point lives on the line or not. If it lives on the line, then yes, it is a solution. If it doesn't live on the line, then no, it's not a solution. So how do we determine whether this point lives on the line or not? Well, it's pretty simple. Let's look at number 2. The ordered pair we're given is -2, -10. And remember, an ordered pair has two different pieces. The -2 here, that represents our x coordinate, while the -10, that represents our y coordinate. So we actually have a value for x and a value for y that I can actually plug in. So instead of having a y here, I'm now going to plug in the -10. So this y will be replaced with -10. Instead of an x, I'm going to replace that with a -2. So now my equation will look like -10 equals 3 times -2, take away the 4. And now we just do some simple math. On the left side, I can't do anything, so I just bring down the -10. But on the right side, I can do some quick math. 3 times -2 gives me the -6. Once again, on the left side, I can't do anything, so I just bring it down. But on the right side, I can do this simple subtraction. -6 take away 4 gives me -10. So we now have the statement -10 equals -10. And you have to ask yourself now, is this a true statement or a false statement? And for most of us, this should be pretty obvious. Yes, -10 does equal -10. So this is a true statement. When you produce a true statement, what that tells us is that this point lives on the line. Or in other words, -2, -10 is a solution to the linear equation y equals 3x minus 4. So if you produce a true statement, this will be a solution. It's not the only solution. Remember, a line goes on and on forever. So there's an infinite amount of ordered pairs that will work. This is just one of those solutions. There's an infinite amount. Number 2 was in slope-intercept form because the y is by itself. So just a quick reminder about that. Now we'll look at number 3. Number 3 is in standard form because your x and y are on the same side of your equal sign. And we do the same steps for if it's in standard form. You have an ordered pair. This is your x, this is your y. You're going to go and plug it in to see if we produce a true statement or not. Instead of 5x, you're now going to have 5 times the 4. I replace the x with the 4. Instead of 4y, you're now going to have 4 times the -3. The y gets replaced by the -3. And you just bring down the equal sign and bring down the +7. Now we do some simple multiplication. 5 times 4 gives me 20. 4 times -3 gives me -12. So I now have 20 take away 12. Or you can write 20 plus -12. It's the same exact thing. And then bring down your equal 7. And then 20 take away 12, well, that's easy. 20 take away 12, that gives me 8. So I produce the statement 8 equals 7. Now ask yourself, is this true or false? Well, this should be obvious. This is false. 8 does not equal 7. So we can actually write a not equal sign. This is a false statement. What that tells me now is that 4 -3 does not live on my line. Or in other words, 4 -3 is not a solution to the linear equation, 5x plus 4y equals 7. And just like how there's an infinite amount of correct solutions, there's also an infinite amount of ordered pairs that are not solutions. So this is just one of the points that's not a solution. There's an infinite amount. We're just asking you to test one of them. Now let's look at number 4. This time you have a fraction, but once again, it's just a fraction. We can take care of that. There's nothing different. We're going to do the same exact steps. This is our x. This is our y. Let's plug it in. Instead of y, I'm going to plug in a 4. Instead of the x, I plug in a 6. Bring down your +2. Well, to multiply a fraction times a fraction, you just do top times top and bottom times bottom. Remember, there's a 1 underneath the 6. I can write this as 6 over 1. So what I have is 1 times 6 and 2 times 1. Well, 1 times 6 gives me 6. 2 times 1 gives me 2. And then 6 divided by 2, I can simplify that. 6 divided by 2, that's simply 3. So I now have 4 equals 3 plus 2. And I could take care of 3 plus 2. 3 plus 2 is simply 5. So I get the statement 4 equals 5. Obviously, that's not true. Those are not equal. This is a false statement. So once again, 6 comma 4 is not a solution to the linear equation y equals 1/2 x plus 2. And once again, this one is in slope-intercept form because the y is by itself. Now let's look at number 11. 3y minus 5x equals 10, and we're going to be checking 1 comma 5. This is just like all the other problems, but this time I try to trick you. I put the y first, and I put the x second. Doesn't matter. Just you may need to make sure you plug your x and y into the correct spots. So I'm going to make sure I plug in 1 for x, and I'm going to make sure I plug in 5 for y. So don't mix that up. So instead of 3y, it's now going to be 3 times 5. Instead of negative 5x, it's now going to be negative 5 times 1. And then I'll bring down my equals 10. We do some simple multiplication. 3 times 5 is 15. Negative 5 times 1 is negative 5. And then we bring down the equals 10. And 15 take away 5, well, that's simply 10. So we get 10 equals 10, and that's obviously a true statement. So we know 1 comma 5 is a solution to the linear equation 3y minus 5x equals 10. And finally, number 13 was just kind of like a bonus question. It says create an equation that has the solution 2 comma negative 6. In fact, this one has an infinite amount of correct answers. There's an infinite amount. I can do this forever and ever and ever, and I will never finish. And I'll show you how easy this is. I'll give you some examples. First, just think about what happens if you add your x and your y. That's a simple equation to create. I can add my x and y, and if I add these numbers, 2 plus negative 6, well, that will give me negative 4. So this equation has the solution to negative 6. Well, what about instead of adding my x and y, what happens if I subtract my x and y? Well, if I do 2 take away negative 6, I get positive 8. So this equation would also be a correct answer. Now, what happens is maybe I put a coefficient attached to my x. So maybe I put a 2 in front of my x. And then I add the y. Well, that would just be 2 times x, which would be 2 times 2, which would be 4. I add the negative 6. 4 plus negative 6 will give me negative 2. And then this third one, I just said, what happens if maybe I flip the x and the y? Instead of doing x minus y, I do y minus x. Well, negative 6 take away 2 will give me negative 8. And finally, what if I just put a fraction in? Let's think about what if I made y equals 1/2 x minus 7? Well, think about the math here. A 2 times a 1/2 is a 1, and a 1 take away 7 gives me the negative 6 that I needed. So these are 5 examples out of an infinite amount that would work. The ones that I came up right away in my brain were the first 2. The other ones took a little bit of thought, but as you can see, it's not that hard to create an equation that has the solution 2 comma negative 6.